Good afternoon, everyone. My name is Farid Seifi, and I'm presenting this work on behalf of Knowledge Systems Lab at Department of Learning Health Sciences at University of Michigan. So today in this demo, I'm going to talk about how our model supports adding structured metadata to computable biomedical knowledge artifacts, and also how our tooling supports creating information pages for CBKs and to perform metadata-driven packaging for them. So before jumping into an example of such structured metadata and how our model supports creating them, I want to briefly mention the importance of adding structured metadata to CBKs. And also I want to mention a few examples of structured metadata and their usage. So just like any other model or object, metadata can be added to CBKs to benefit from different aspects. For example, metadata can contain information that enable discoverability and indexing. It can facilitate interoperability. It can capture provenance and attribution. It can describe context and scope of the CBK. It can track version control and updates, and so many other usages that are not even listed here. So as examples of structured metadata and their usage, you might already be familiar with model card reports. For example, Hugging Face model cards, or Google's Model Garden, which uses the same idea. Those model cards are created using a structured metadata. So structured metadata is added to the model and accompany them, and then the model cards are created using those metadata as handy information that accompany the model and are used by different stakeholders who want to use those models. So that's one example of metadata and their usage. You might also be familiar with packaging software for distribution. For example, if you have a Python package and if you want to publish it on PyPy, you need to include metadata to facilitate that process. So now let's take a look from a high perspective to an example of such a structured metadata for CBK. So our model supports describing a knowledge object in the metadata. The knowledge object can have multiple knowledge elements. It can have multiple services defined. Services are ways to access the knowledge inside the knowledge object. So each one of the knowledge object, knowledge, and services can have multiple tests defined for them. And then each one of the items in green, the knowledge object, knowledge, service, and test, can have multiple documentation defined for them. So as we see, our model supports multiplicity. The metadata here are formalized by Koyo ontology from our group, and metadata are linked data in RDF formats that can be processed by machines. So now let's take a look at a more detailed example of such structured metadata. For the purpose of this demo, I'm going to use one of the United States Preventive Services Task Force recommendations, the abdominal aortic aneurysm screening recommendation, which we have implemented using Python, and we have added metadata to it. So this is a simplified version of the metadata. At the top, we have the administrative and descriptive section where we talk about the type, title, version, date, description, publisher, license. So for the descriptive and administrative section, we use most of the terms from existing ontologies like Dublin Core. We only have one term defined in our ontology, knowledge object, to type this element. The next section, which is a more technical section of the metadata, we have in this example one piece of knowledge defined for this knowledge object, and this knowledge has its own ID. It's typed as knowledge, and it points to the implementation of the knowledge. Next section describes or adds a service to this knowledge object. It has its own ID. It's typed as service. It shows which pieces of knowledge it depends on, which is the knowledge defined at the top. And also it points to the implementation of the service. So considering we have this type of structured data, we have been looking at different ways that we can use it. For example, we have explored making human readable documentation from metadata. We have looked at packaging CBK artifacts using metadata. We have also looked at feeding CBK metadata into large language models to create chatbots. we also explored making metadata available to search engines. And this list is still going on. We are still looking for other ways that we can use such structured metadata. But for the purpose of this demo, I'm going to focus on the first two items here. So we will see first how our tooling supports using structured metadata to auto-generate an information page, which is a more human-readable documentation from the metadata. And then we will look how the structured metadata can be used to perform metadata-driven packaging and include everything that's necessary for the knowledge object and pointed to from the metadata in a package. So let's switch now to an implementation of the knowledge object we have been looking at, the abdominal aortic aneurysm screening. Here in this folder, we have the services and knowledge implemented here. We have other files like tests are included. There is a license file, metadata file, documentation, and some other files. But let's take a look at the metadata file. This is a more complete example of the metadata we have looked at. Again, we have an administrative and descriptive section at the top. We have one piece of knowledge defined for this knowledge object, which we will look at it in more detail. So this knowledge has its own ID. It's typed as knowledge. It points to the implementation of the knowledge. It has some more administrative and descriptive information for the knowledge. For example, it shows where is the source of this knowledge and what was the date it was created and who is the creator and so on. This knowledge element has two different tests defined for it, and each one of these points to the implementation of the test. There is one piece of documentation defined here for this knowledge as well. And the next section has three services defined for this knowledge object. So each one of these services has its own ID. It's typed as service. It shows which piece of knowledge it depends on, and it points to the implementation of the service. And then at the end of this metadata, we have two different pieces of documentation defined for the whole knowledge object. So now, considering we have this structured metadata, we want to use our tooling to create a more readable documentation and information page for this knowledge object. In order to do that, we can use our KGrid SDK, which is published on PyPy, so we can install it using a command like pip install KGrid SDK. And then once it's installed, we can run a command like KGrid information page, and then we just need to provide the path to the metadata and then a path to where we want the information page to be created. So if we execute this, an information page is going to be created here. And then if I open that in the browser, here is how it looks. We have the administrative and descriptive section of the metadata showing here. We have services listed here, the three services that we saw in the metadata. The knowledge is listed here with its all details. The documentation and tests are listed on the right side. So before looking at some of these links, I just want to mention that once the command is executed to create this information page, it's going to look at the location of the metadata and how it's linked to a GitHub repository, and it will take the IRI of that GitHub repository and resolve all the relative links in the metadata towards that IRI so that we would be able to click on these links for the relative links and see the item behind them in the GitHub repository. For example, the ID in the descriptive and administrative section is linked to the main page for this knowledge object on GitHub repository. So we can click on that and explore all the files on GitHub. The license, for example, is linked to the file that's that includes the license information on GitHub repository. If we look at one of the services, the command line service has a link to the implementation. So if we click on this, it's going to bring us to the Python file that implements that service. The same for knowledge. the tests and documentation are linked as well. Some of these links might be external resources. For example, the first link in the documentation is a link to a page on USPSTF website for abdominal aortic aneurysm screening. The second link is a link to a Jupyter notebook on Google Colab that we have created for this knowledge object, and it includes all the information that's needed for to find out how this knowledge object can be used and integrated in other applications. There is a link to the README file in the documentation as well. The tests are clickable, so we can click on each one and see the implementation of the test. So now that we have this human readable version of the metadata, the information page, we can see how this can improve FAIR principles for the metadata. For example, this information page can be indexed in search engines and improve the findability. It's more readable, human readable, and it provides access to all the links and information that is mentioned in the metadata. So it improves the accessibility in that sense. It improves interoperability because now different stakeholders can find this and can easily navigate through the documentation that can help them integrate this into their applications. So it improves the interoperability in that sense. And of course, it improves reusability because now people can find this, see how it works, look at the test, and find out how this could be used, and then they can reuse it in their applications. So let's go back to the example. And now let's say we want to perform metadata-driven packaging. So we can use our tooling to do that. We can call a command like kgrid package and provide the path to the metadata file. And then once this is executed, a tar.gz file, a zip file is going to be created here that includes everything that the metadata is pointing to. If I unzip that, just to show you, this is the folder, and we see that the implementation of the knowledge and service are included here. The tests are included here, license, metadata, README. We are still working on adding all the external resources that are linked to from the metadata. So once that feature is completed, we can assert that this feature can help create a package for the CBK and include everything that's necessary and needed and the metadata is pointing to in that package. And then that could be considered as one way of sharing this CBK with the world. So if you go back, these were the two different ways that I wanted to show you on how the structured metadata can be used. And as I mentioned before, this list is still going on when we are looking for other ways that we can use the structured metadata to improve FAIR principles for the CBK. Thank you.